In this video, I'm going to be attempting to revive this super rare iPod Touch 2nd generation development board. Now, I actually got this board off eBay for about $45, which for something this rare and unique, that is definitely quite a decent deal if I would say so. So what I'm going to do in this video is I'm going to attempt to get this board working. Now, in its current state, it is not fully working. However, it is partially working. And if we go ahead and flip it over here, you can see immediately why it's not fully working. And that, of course, is because one of the main components on here, the NAND, has been removed. Now, this is something I'd probably expect for a device like this, considering when it was probably recycled or gotten rid of by Apple after it was done being used. They probably pulled, or at least had somebody pull off all the NANDs. That way any software that was on these, that may have been Apple internal or whatever, was completely missing and unable to be recovered. So what I'm going to do to rectify this is I'm actually going to take parts from a production iPod Touch 2nd generation, which I've got right here. You can see that this device is not in very good shape at all, which is exactly what I wanted. I didn't want something in good shape that I'm just going to take apart and pull parts from. But this is nonetheless a fully working iPod Touch, as you can see right here. Now, I have jailbroken it just in case I need some sort of jailbreak feature when I boot this NAND on here, assuming it even boots at all. This is obviously a huge unknown at this point, but if I get lucky enough, I might be able to just have this dev board just boot into this copy of iOS that's already on this NAND. And if that's the case, then I'll have some tools that I can use potentially to interact with the device. And I'll show you why interacting with the device in the case of this is going to be a challenge in a moment once I get this iPod taken apart. But the first thing I want to show you before I start taking this apart is show you what this actually does as it is when you try to plug it into a computer. So I'm going to get a computer up here, and then I'm just going to plug this in without doing anything to it. Just plug in the 30-pin dot connector here via a USB cable to a computer. So I'll get that computer and plug that in and show you what it does. Alright, so you can see here I've got a computer here running a copy of Snow Leopard, which of course has an old version of iTunes, which will need to interact with these devices. And I've got the device right here, the dev board, plugged into its 30-pin cable. Of course, the other end is not plugged in yet. But I'm just going to go ahead and plug it in now, and I'll show you what it does. Okay, so the device is plugged in. You can see that it has an LED on there, and actually the computer is already detecting it. And this is all it does. So let's go ahead and exit out of that. The next thing I want to show you is what it shows up as in System Profiler, just to show you that it is indeed detected here. And there it is right there. You can see it's detected as a USB DFU device, and you can see it's got the usual device IDs of a DFU device right there. But the one thing you'll notice is the serial number, which normally shows you actually a bunch of info like the iBoot version and stuff like that. It's just a random string of numbers here. And of course, that data is normally retrieved from the NAND on a normal iPod Touch. Now, I think in theory, based on this, that installing the NAND from a production iPod Touch will at least partially rectify this. Now, there is a chance that the actual system on a chip, of course, the chipset located right there, has a different bootloader on it, which, based on what I've seen, I think might be the case. But we'll obviously try it and just see what happens with the stock production iPod Touch NAND installed. So with that, I'm going to go ahead and get the production iPod Touch right here fully disassembled, take the logic board out, and we'll compare its logic board to the little logic board here on the dev board. You can actually see that this little section down here is actually literally an iPod Touch 2nd generation logic board, just like the routing and the component placement and everything is the same, but it's just of course expanded onto this dev board. So with that, I'm going to get the iPod Touch taken apart and we'll go from there. Alright, so as you can see here, I've gotten the iPod disassembled and the logic board removed. I've also removed this metal can that was around the NAND and the CPU here, and you can see that right off the bat, the design between like the routing and component placement and everything between the dev board and the production iPod Touch 2nd generation logic board are pretty much identical. Now, one thing you might notice is that on the dev board here, there are some circuits that are not populated. So you can see that set of pads there and all those support components are not populated. Same with those components right there. But if we look at the production board, you can see that those components are populated, and same with those components there. So you can see actually that circuit looks significantly different as well. So I'd assume that these particular circuits here are for hardware that are in the production iPod that's not on this dev board. So for example, the speaker is not on this dev board, so this may be an audio amplifier or something like that. And this might be something to do with audio output of the 30-pin dock. I really don't know. Maybe I'll be able to find a schematic for this board, and then we can figure out what some of those circuits do and potentially populate them if we desire to do so. But let's flip the boards over here, and I've got the headphone jack here from the production board, and let's take a look at the differences between the top side of the boards. So once again, we've got the production board here. Everything pretty much is populated. But if we look at this board, you can see we've got a couple chips right there that are not populated. And that small BGA there is actually a backlight IC for the LCD. So despite having the connector for the LCD there, as you can see, the backlight circuit is not populated. So I found that kind of interesting. Of course, we will be populating that circuit using the backlight IC and that little capacitor and stuff from the production board. But you can see there's also another chip right there next to it that might also be part of the backlight circuit. You can see that chip is populated on this board. And one thing you might also notice about the production board here is that all the chips and everything, all the components, have underfill on them, which is a little unfortunate. Makes the removal of the components a little bit more difficult, but nothing we shouldn't be able to take care of. And actually, if I flip it back over again, you can see that NAND, despite being a TSOP, NAND is also underfilled, so that's a little annoying, but we'll make our way through it. We'll get it off. So of course the next thing we need to do is just that. We need to remove the NAND from this production iPhone or iPod Touch 2nd generation logic board. So I'll get the camera positioned on the tripod here and show you that process. Alright, so I've got the board in position to start working on it here, and I've gotten my underfill tools out. So we've got two tools on this. The first one is a little hook tool right here, and this is just basically very, very thin metal, and this is going to allow me to scrape away the underfill on the perimeter of the chip. And then on the other side of the tool, I've got this tool, which I'm going to shove underneath the chip to kind of get rid of the underfill and then pry the chip off. So I have done this a couple of times before, and I have had pretty good success with it. So I'm just going to turn on the hot air, and we'll begin the process of removing this NAND. Alright, and that's the NAND successfully removed. So now the next thing I need to do is get the NAND up on a tray here, and then I need to clean all of the underfill off from underneath the chip. And it actually looks like most of it stayed with the board, which is good, but I am going to get it and clean it just to be 100% sure that there's no extra underfill on there, which will cause issues when soldering onto the board. Alright, so after inspecting the NAND pretty closely, it looks like there's not much underfill. Actually, there's pretty much none at all on it. There is some around the pins here, but if you look at the bottom of the pins, the part that was actually soldered to the board are still fully clean. So I don't think there's going to be any issues soldering it on there. And getting the underfill out from between all these pins is going to be nearly impossible to do, so I'm not going to bother with that. You might be able to make it out. There's a bridge here. I don't really know how that happened, but I'll clean that off with the soldering iron after we solder the NAND onto the board. So the first thing I'm going to do is apply some flux to the pads and tin it up with some fresh solder. So we're just going to take some fresh solder here and just put it on all the pads. Okay, so we've got some nicely tinned pads there, so now I'm just going to take our NAND and align it appropriately onto the pads on the board. And just like that, it's all aligned. So now I'm going to take the hot air and just heat it until it solders onto the board. Okay, so that looks pretty well soldered there. So the last thing we need to do is just remove any bridges. So there's just that one bridge right here. So we're just going to apply flux. Take the clean iron here and simply tap it. And that's it. The bridge has been removed. So in theory, the NAND should be fully soldered. So I'm going to get everything cooled down here, and we're going to plug the board back into the computer and see if the results are any different. Alright, so as you can see here, the NAND is fully soldered. I have checked all the solder joints just to make sure everything looks good, and it does. So I've also got an LCD plugged in just in case. I just plugged it in right where the LCD normally goes on these, and I just took the one right out of that iPod that I took apart. So hopefully we get something different, though. Like I said, I'm not really too confident about it, but let's plug it in and see what happens. And it seems to be doing the exact same thing, so let's see. Yep, exact same thing. Let's check System Profiler here, and there it is. And there's absolutely nothing different with it there, so I think that's probably due to either some weird bootloader. I think from what I've heard about these specific dev boards, the chip on them, the SOC, has a different bootloader than a stock production iPod Touch. And that's probably the issue, because the NAND obviously is for one that has, an iBoot ROM, whereas I think this has what I think it's a Samsung ROM, such as the original iPhone shipped with. So unfortunately, I don't think there's really anything I can do with this chip. However, and I don't really want to do this, but I don't see any other option at this point. What I think I'm going to try to do next is I'm going to take the SOC off of the production board, so this SOC right here, and I'm just going to solder it onto this board. Now I know that can be considered a little bit of a disappointment, because of course the chip on the dev board is going to be, a prototype or some odd chip, which in the case of what it's doing now is definitely the case. But to me, I'd rather have the dev board be fully functional than have, it be completely stock. So I think I'm just going to take this SOC off of this production board, reball it if I can. Hopefully I have a stencil that'll work with this, and solder it onto this board. And in theory, that should get it up and running as intended. So with that, I'm going to go ahead and get this back on the table here, and we'll begin desoldering the original, or the production, SOC. Alright, so I did a little bit of experimentation and I actually populated the UART chip right here, as you can see here. This is just a standard SP3232 RS-232 to UART adapter chip here, or converter chip rather. And I wasn't able to get any output out of that. I also connected some wires directly to the UART, which are these pins here, and tried to get some output through those as well. And unfortunately, that also did not give me any sort of output. So it seems like despite this thing going into DFU mode, it doesn't do anything else from there. So I guess the only option at this point is to remove the original SOC from our production board right here and just solder it onto this board. Now, I don't have the correct BGA stencil for this chip. I did look around to see if I could find one. So I'm gonna try to just tin the pads on both the board and the chip in lieu of reballing it. Now, while that's not the best idea in the world, I have had that work with some success in the past. So that's exactly what I'm gonna try. So of course, the first thing I'm gonna do here is get this chip off and clean it up, and then we can go from there. Alright, so as you can see, I did get the chip off. Now this chip is actually technically 2 chips in one. There's actually a RAM soldered to the top of the chip, and I'm not exactly sure if that got damaged or not during that process. Obviously it's BGA soldered to it, so there's a chance, you know, some of the balls got messed up. But I won't separate them yet. Before I separate them, I'm just going to try to put it on as it is and see if it does anything. And if not, then I'll go back and take the RAM off and try to reball that. So I've got the hot air in this holder here. That way I can use 2 hands, one to hold the chip and one to clean it. So we'll go ahead and get it turned on now and begin cleaning the remaining underfill off of the chip. Alright, so now that I got all the underfill cleaned off the chip, the next thing I'm going to do is apply some flux to it and get some fresh solder applied. Like I said, I don't have a way to reball this, unfortunately, but I think this method should work okay. We'll see. Alright, so after doing a little bit of digging around, I actually did manage to find a suitable stencil. And as you can see here, I've already got it in the stencil right here, the chip, of course. So what I'm going to do now is just reball it using some solder paste, and hopefully all goes well. The surface of the chip doesn't look exactly perfect. It got a little bit of damage from the underfill removal, but I think it's good enough that it will still work. Start by just applying some solder paste to the top of it here. And obviously this isn't the correct stencil for this chip, but it is the correct size holes and the correct pitch, which is all that really matters in most cases. So now that the paste is applied, we're going to spread it out into all the holes. Okay, and that looks pretty good there. Actually, I need to apply just a little bit more there. So now we'll just heat it, and hopefully it reballs as expected. Alright, so all the solder balls, or all the solder paste has melted rather. Go ahead and pull it off. Alright, so as you can see, that didn't quite work as expected, but it almost did. So I'm going to try that one more time off camera, and hopefully the second time I'll be able to get it to reball fully and properly. So that way we can actually solder it on and have a chance of it working. Alright, so it's been quite a few weeks since that last clip you just saw there when I was reballing that production SOC, and that ended up being probably one of the hardest, definitely the hardest thing that I've ever had to reball, mainly because I just didn't have the correct stencil for it. But after 3 attempts, 3 different iPods, after messing up 2 SOCs, or messing up 3 SOCs on my 4th attempt. This is the 4th SOC that I've tried here, and I finally managed to get it reballed successfully. And I ended up having to actually use solder balls instead of solder paste, which was even more of a pain. And to top it all off, I ended up also having to separate the 2 packages. So these are a package-on-package design with the SOC on the bottom and the RAM on the top. You might be able to tell by looking at that. Let me go ahead and turn the light on here. You might be able to make that out here on the SOC. So yeah, you can see the top part has its own set of solder balls that solder it to the bottom part there, and then the bottom part is what actually solders onto the board. So, and I also didn't have the correct stencil for the top part either, and that one, the ball out is so strange that the grid, it's not to an exact grid pattern, and in fact I can show you that here with one of my previous attempts here. So here's the bottom section here. You can see it's got the pads that solder to the board on that side, and then the side for the RAM on this side. And to make it even more difficult, there's a part of it in the middle here that sticks up. Of course, this is where the actual SOC silicon is. So you have to put extra large solder balls on these pads so it actually takes up the gap between the top of the SOC part in the middle here and the bottom of the RAM. So here's the bottom of the RAM here, and you can see its pads look like this. So you have to apply solder balls to make the height of those solder balls high enough that it bridges the gap between this protrusion in the middle and the actual pads on the sides. And then if you see how there's a space in between one of the sides there, you can see that there's that row of 2, a gap, and then that single row on either side. The spacing in between that is not the same as one ball. So if you line these, the row of 2 on each side up with the stencil, if it's just a normal grid stencil, which is all I had to work with, the single rows here on either side do not line up with any holes on the stencil. So I actually had to reball all of those manually by literally placing solder balls one by one with a pair of tweezers and then heating them and getting them all soldered onto their pads. But after spending an insane amount of time doing that, as you can see there, I have successfully gotten it done, soldered on the board, and it is indeed working so far. So, I did test this off camera, of course, because I just wanted to get this done because I had spent so much time on it, and I found one other weird issue that I had to work around, and that has to do with this chip right there. You see that little piece of silicon? I'll point it out to you with the tweezers right there. Well, that is a SPI EEPROM, and this is actually what's used as the NOR flash. It's what's called the NOR flash, and this contains various critical pieces of information like the system serial number, the NAND configuration, as well as quite a few other parameters in there, including NVRAM. Now, I transferred this from the same board that I took the SOC from to make sure all of that would match, just in case. I'm not sure if there's any matching that actually goes on there. But I took the NAND SOC and the NOR EEPROM there from the same board, and it still didn't work, and I couldn't figure out why. So what I ended up having to do was I had to compare these strap configuration resistors located right there with the configuration from a stock board. So let me go ahead and zoom in here and show you exactly what I had to do. So if we first go ahead and take a look at a second board, you can see right here, this one I've taken the SoC off of just so I could probe some pads on this one and basically to figure this strap configuration out. And based on what I found, you can see how this strap configuration is. The center area, let's see if I can point this out better, it's kind of hard to do here. These center pads here are all ground, and the pads on this side, or the pads on this side are all ground, and the pads on this side are all VCC or 1.8 volts. And then you can either set the resistor on this side or this side to either set that strap high or low. So what I found is this strap is high on the dev board, or yeah, this strap is high and the rest of them are low. However, on the stock board, and this is what I replicated here, this strap, this uppermost strap is high and the rest of these straps are all low. So once I replicated that, it started working immediately. Before I set that strap configuration, it literally just would not read any data from this NOR EEPROM here. But after setting that strap, and I had to figure that out by literally probing each pad underneath the SOC, which I use this board for, to figure out which of these straps went to which pin. And then I had to compare that with the production board, which is not, the routing here is not the same. So the pins go to different resistors, although they're all in the same spot. The resistors that are not in the same order corresponding to the same pins. So I had to basically probe each one of these out, figure out which each of these straps corresponded to, and then replicate that config on this board. And sure enough, that got it working. So I was able to perform a DFU restore, which I will show you in a second. We'll do that again. But so far I have not been able to get the screen working. So let me go ahead and hook this all up here, and we'll do a DFU restore, and I'll actually show you exactly how that works. Alright, so I've gotten my restoration setup going here. You can see I do have a serial adapter plugged into this UART port, and I've got that open on a terminal right here, as you can see. So hopefully we'll get some sort of output out of that while we're restoring. That would be pretty cool to see. I've also got a 5-volt power connection in from this bench power supply right here. And of course, I've got our 30-pin cable connected from, or that we will be connecting to this MacBook right here, which we'll be using to restore the device. So with that, I'm going to go ahead and hold down this DFU button right here to put the device in DFU mode and plug it in while holding that down. That way it goes straight into DFU mode when it gets power. So hold that down. Go ahead and plug the device in. You can see the device is now on, and I'm also going to turn on the 5-volt power supply here to make sure it has enough power. We don't want it to, die during the restoration process. And as you can see here, the device is in DFU mode. Now you can see it's actually detected properly as an iPod Touch here. And if we take a look at system report here, we go to USB, you can see that it detects this device right here, and you can see it has all this extra info down here. And that, of course, is using that built-in iBoot boot ROM into that production SOC, which the prototype SOC that was on this board did not have, which is why it wasn't being detected exactly as you would expect. So with that, let's go ahead and restore the iPod here. So we're going to go ahead and select Option here. And I've got a copy of iOS 4.2.1. I do want to obviously put an older version on once we test everything and see how it works. But for now, I'm just going to restore the latest and see if it actually will allow me to do so. Let's go ahead and open it here. Select Restore. Oh, we're actually getting some output on the console here. So that's pretty interesting. Let's see if we get any more here. You can see it is doing stuff. No more output on the console. The iPod went into recovery mode, but I'll try it one more time and see if that makes any difference here. Alright, so I don't know what happened that first try, but look at that. I just tried doing the restore a second time, and it's actually working now. Well, this should take quite a bit of time to complete, of course. So I'm going to let this run, and I'll resume the video once I have some sort of result. Alright, and look at that. The iPod has been successfully restored. So hopefully it just reboots, and in theory, once it does, it should show up in here as a new iPod. So we'll wait here and see if that actually happens. It is actually pulling a little bit more current from the power supply here. which is a good sign. I don't know why it opened photos, but quit that. And there it is, look at that, iPod Touch. And of course it's only 8 gigs because that's the size of the device that I took the NAND off of. And look at that. I'll just say set up as a new iPod. Let's see if we get anywhere here. And look at that, there it is. You can see it detects the serial number. That serial number is from that donor iPod. Of course, it's stored in that NOR EEPROM that I showed you earlier. We're running the latest iOS 4.2.1, which of course I do want to downgrade. Maybe if I can even put a development build of iOS on here, that would be kind of cool. But that's of course a project for another day. So now the next order of business here is to see if we can actually get the screen working on this device. Now, I did try it before, and so far I haven't been able to get it working, but maybe now that we have actual software on here, it will work. So I'm going to go ahead and hook up a screen, and we'll see if it actually works. Alright, so as you can see here, I've gotten a screen hooked up to the LCD connector that's on the board right there. I've got everything still connected, the 30 pin, not plugged into the computer yet. But we're just going to start by applying 5 volts from the power supply to the board and see if anything happens. Okay, they're on there, the LEDs are at least. So hopefully we get something on the screen. It's pulling about 100 milliamps there. So far nothing. I figure something with this LCD debug connector. It's got a few jumpers in it. This is exactly how I had it here when I got the board, of course. So maybe we'll try messing with that. But I don't see anything on the screen. Let's plug it in and just make sure it's actually booting. I figure it's still probably booting up here. Alright, it definitely did boot. But of course we still have nothing on the screen, which is a little unfortunate. Yeah, so you can see iTunes does detect the iPod again. It is fully booted. But we do not have anything on the screen. So I will have to look into that more. I do have, like I said, a reference of course, a stock production iPod Touch. So I know there are some parts missing down here, namely the backlight controller right here. So that's probably going to be at least an issue for backlight, but there's still no image on the screen at all. So we'll mess first with this jumper here, this set of jumpers here, and we'll see if we can figure anything out with that. I'll do a little bit of continuity testing and voltage testing and see if I can figure out what these actually do. But once I do figure something out, I will update you and show you exactly what the issue was. Alright, so after doing a little bit of buzzing out and just some experimentation basically, I actually figured out how to get the screen working, and it actually ended up being way easier than I initially thought it would be. So literally all I had to do was populate some more of these jumper pins here, and you can see I populated all except the end 2 spots there. So we've got 6 jumpers in there in total, and not only did this get the screen working, but it also got the backlight working, even though the backlight controller is not even populated on the board, which would be those little BGA pads right there. So I found that really interesting. I guess it's just sending voltage from one of the power rails straight to the backlight in the screen, which of course means the backlight brightness can't be controlled, but I don't really care about that, honestly. So with that, I'm going to go ahead and turn on the power supply, give the board the 5 volt power it needs, and we will see that the screen does indeed now function. And look at that, straight away we've got power to the board, the screen is on, and you can see the Apple logo, which of course means the device is indeed booting. You can see that's all I've got connected right there with those extra jumpers installed, and it just works as intended, which is very surprising, honestly. So we'll let this boot up, and I'll show you that it fully boots and has the image of the lock screen that you'd expect. And look at that, the iPod has fully booted. And of course we can't actually interact with it because this is just the LCD, not a touchscreen. But that will be the last thing we need to solve in order to get this to be a mostly usable device, which is kind of hilarious. So, the touchscreen is going to be a little more complicated than everything else, and I'll show you why in just a second. But overall, I'm still very happy that we did get the screen and the board itself fully booting and working with iOS, and that's pretty amazing in my opinion at least. So let me go ahead and get a production iPod out here, and I will show you exactly why the touchscreen portion of this is going to be a little bit more difficult. Alright, so as you can see here, I've got a production iPod board out here, and for any of you who have ever messed with these, you would know that the touchscreen does not plug into the logic board, rather it plugs in up here. And this is why this is going to be a problem, because the touchscreen controller chip is located right here. But luckily for us, this chip is simply connected to the rest of the system over SPI. So it's only 4 lines, SDA, SCL, SDO, and I believe a chip select line. It's just a basic SPI bus. So what we can do here is we can actually cut this portion of the board off, or this flex ribbon cable. I don't know if I'm going to cut, or I'll probably desolder or something, the whole thing, or if I just want the touchscreen part of it up here, because the Wi-Fi is also located on this ribbon, and of course that's what's going to use most of this I/O here. The Wi-Fi chip is actually located under here, and you can see the antenna is just this fancy little ribbon wrapped around this plastic piece right there. So the touchscreen part of it is simply connected to the rest of it over its own little ribbon cable, and I might just take this off, cut this, and then strip off the insulation and bodge some wires to this board, but I'm not exactly sure what I'm going to do yet, so we'll see once I get this all taken apart here. And I have already buzzed this all out, and it actually, this set of solder pads right here is basically the same I/O as this ribbon connection right here. Of course, that's soldered. There's no sort of connector or anything on that, so I'm going to have to either desolder or cut this, and then solder to the correct pins of here that connect to the SPI bus that the touchscreen normally connects to on the SOC. So I'm going to work on that off camera, because that's going to be quite tedious to film and show everything in that regard. But we're going to go ahead and attempt to do this and see if we can actually get a working touchscreen on this dev board here, which would be obviously the completion of this whole project here. So with that, I'm going to go ahead and work out what pins need to be connected, which I've already sort of done, and see if I can actually get those pins connected to this ribbon cable assembly here. Alright, well unfortunately, despite my best efforts in trying to get that touchscreen controller to work with this board, I was unable to do so, and it was not because of the SPI lines being an issue. It was more because of the power lines and potentially some enable lines that are present, or that the ribbon cable is expecting on these, that I wasn't able to figure out the correct pins for. And of course, I could figure that out if I had a schematic for the second generation iPod Touch. Of course, I don't expect to find a schematic for this dev board, but a production iPod Touch second generation schematic would have allowed me to get that working. But unfortunately, I did not have one, so there was really nothing I could do. I looked everywhere for one. I couldn't find it. I even tried to literally connect every single pin that this board had circuitry to drive on this connector, and that took quite a long time, as you can see in this photo right here. It ended up being quite a mess as well. But what I ended up opting for instead was I managed to get the device to be controllable over USB through SSH and through VNC to actually interact with the user interface on the device. So that's exactly what we're going to do right now. So with that said, let's go ahead and get this device powered on one more time. And we'll let it boot up here, and then we'll interact with the device over VNC from a computer, since obviously we have no way to get touch input into this at this point. And I'll show you exactly how everything works on the system. Now, of course, in order to get VNC working on here, and of course SSH, I did have to jailbreak it. Of course, that's pretty trivial these days with such an old device. So we'll just go ahead and let this boot up here once again. As you can see, it already booted there into iOS 3.1.3. So now what I'll do is I will get a 30-pin connector installed here, connect it to a computer, and we'll connect to the device via VNC over USB. Alright, so as you can see here, I've gotten the device connected to the computer. So over here on our computer, I've got a tool installed called libusbmuxd, I think is what it's called. And it's got a tool included with that package called iProxy, which you can use to forward a port on a iDevice over USB to a local port on a computer. That way I can connect to the device to a network interface or network protocol such as VNC over USB. So we'll go ahead and run this command here, and now that port is open. So what we can do is just go connect to server here in Finder, and we'll just simply connect to localhost, and then the port that I forwarded, port 5900, which of course is the VNC port, to on my local machine here. So go ahead and connect here. You can see it detected the connection there. Type in the password, and there we go. There's the device over USB, over VNC, so we can go ahead and slide to unlock just like that. And there we go. We've got a home screen up and running on the device, which is pretty cool. So with that, let's go ahead into settings, go to general, about, and we can take a look at the info here. So you can see that I've installed iOS version 3.1.3 on this device. I may try to downgrade it to an even earlier version, but honestly iOS 3 is fine for something like this, which is basically going to end up being a display piece, because obviously there's really not much use for a board like this, especially without a working touchscreen. But you can see there, it detects it as a PC model. I've never really seen that before. I know some model, I know there's usually the MB model and MC model iPod Touch, but I think PC may be like an Apple replacement device or something like that. I'm really not sure. You can see Wi-Fi is not detected at all, same with Bluetooth. Once again, that is part of that ribbon cable assembly that also has the touch controller on it. If we go ahead and head back here, to the main page, you can see Wi-Fi. It just simply says no Wi-Fi, of course, because that's not installed. And as I mentioned earlier, I thought backlight brightness control might not work, but it actually does. So if we take a look at that, you can see I am able to successfully change the brightness, and that's because what I thought was the backlight IC, which I pointed out to you before as those BGA pads right there, is actually not a backlight IC at all, and is in fact a speaker controller or a speaker amplifier for that little internal speaker that the second generation iPod Touch has. So with that, let's go back to the home screen here. You can see that I did jailbreak it. We've got Cydia on there, and that's just lagginess from the VNC. But yeah, it runs just as you'd expect an iPod Touch second generation too. Like I said, I am sort of disappointed that I had to replace the system on chip with a production one, but for the goal of this specific board here, that's really all I wanted. I just wanted this dev board running fully functional with iOS on a home screen that I could just use as a display piece. So with that, that has been the full restoration of this prototype iPod Touch second generation development board, taking it from not booting at all, basically with no NAND on it, of course, is how I got this, to a fully functional device, or at least a mostly functional device. So my future plans for this is I'm going to make like a little enclosure for it to actually make it look a little bit better than just a screen hanging off of it like this. And I'll just make it into like a little display piece in like a clear box or something like that. So I will make another video about that in the future when I get around to doing that. The last thing I wanted to update you on here is I was recently, as in the past couple days, able to get another one of these development boards that actually still has its original NAND and firmware still on it. So I might be able to use that to get one of these devices working with its original SOC still installed. So that would be pretty cool. And once I get the necessary adapter for my programmer, I will of course dump that NAND and provide that dump in a link in this video description once I get that and make that available. So with that, that has been the full restoration of this iPod Touch 2nd generation development board. Hope you enjoyed this video.